All right, so we're here to talk about the five major chemical reactions. There are more than this, but these are the ones you would typically find. And so we'll start. The first one usually is called synthesis because you are synthesizing something new. And a synthesis reaction is essentially when you have two or more chemicals and they make one new one. So basically, it's you putting a bunch of ingredients together and you're making something new, and that's synthesis. An example of that might be when you take hydrogen and oxygen and you make water. And I gotta balance that. But that is taking two ingredients. We're taking hydrogen, we're taking oxygen, and we're ending up with one. They might say, well, what about this two? Aren't there two water molecules? We don't care how many we're making. The point is there were two types of chemicals before, and now there's one type after. That's synthesis. And it could be five, six, it could be any number of chemicals, as long as it's more than one becoming just one. The opposite of that is known as decomposition. So that's when you take a single chemical and break it down into individual chemicals, or not always individual, but smaller ones. And it could be two, three, four, it doesn't really matter. So an example of this might be if I take calcium carbonate and I break it down into calcium oxide and CO2. So this was one chemical before, and now it has become two chemicals. So that is a breakdown, it is a decomposition. So these two are kind of, their name implies, pretty much all it is. You're either making one thing out of multiple, or you're making multiple things out of one. So synthesis and decomposition. The next two are the ones that are usually the ones people have the most trouble with. So the first is called single replacement. And that is when you have a single chemical match up with a compound, and that single chemical is going to replace one of the elements in there. So if A and BC get together, maybe we end up having B by itself and AC with it. So this is sort of the, to use a high school relationship analogy, somebody's single and they cause a breakup, and then that single person now is getting together with one of those in the couple, and then somebody else is single as a result. That's the sort of analogy here. And there's tons of these types of reactions. You can have lithium react with copper nitrate, perhaps, and then copper gets kicked out, and then lithium ends up reacting with nitrate. And I guess I should probably balance this just to, again, it doesn't matter how many. All that matters is that an element that's by itself reacts with a compound, and then another element's by itself after, along with a compound. That's what makes this single replacement, is that at the end of this, one of the atoms is single again. It's one starts off single, and one finishes as single. All right, next, you might guess, we have double replacement. So double replacement is when you have two couples, they both break up, and then they start dating the other one. So if A is with B, A and B break up, C and D break up, and then A and D and B and C end up in relationships. So basically they're just kind of switching, and that would be double replacement. And again, there's lots of examples of this. I could have NaNO3. Well, I'll wait until the next page to show you an example and how that's different from single replacement. There's one other type that we can deal with called combustion. And combustion is just what it sounds like. It's burning. And anytime we burn something, we have some chemical. I'm just going to call it X. We don't know what it is necessarily. It reacts with oxygen, because that's when things burn. And whenever we're burning, it's usually making CO2 and water. So if you ever see some chemical reacting with oxygen to make CO2 and water, that's combustion. So those are the five types of reactions. So on the next page, we're just going to go through these examples and kind of answer some questions. So what are these? So this first reaction, are they making one thing? No, we have two things on each side. So this is some type of replacement reaction. We have calcium by itself, and AgNO3. And it appears that calcium is now with NO3 after the fact, and Ag is by itself. So this is replacement, and this is single replacement. Because there was something single before, there's something single after. This next one, I have one chemical that's breaking down into two chemicals. So that is going to be decomposition. It is a breakdown of this substance. Here I have C6H12O6, and it's reacting with oxygen to make CO2 and water. Again, this is the example of combustion. It is burning, and that's sort of outside. It's the fifth type of reaction that we deal with. Next, xenon and fluorine are making one chemical. So two chemicals are making one. That is known as synthesis. All right, here we have two chemicals on each side. What's going on? Well, I see calcium is with chlorine and sodium is with oxygen. But after, calcium is with oxygen and sodium is with chlorine. So they appear to have switched. Calcium went with oxygen and sodium went with chlorine. So it was a double switch. So this is a double replacement reaction. Down here, I have F2 by itself, and I have LiCl. And what is happening here? Well, now F is with Li. So Li and F mixed, leaving Cl alone. You may say, well, it's Cl2. It's still just chlorine. So this is known as single replacement. So if an element is by itself at the end, if it's single at the end, that's single replacement. Next, again, I see the O2, the CO2, and the water, combustion. And lastly, you can look really quickly. I have aluminum and is afterwards getting with OH. I have calcium getting with SO4. It's a double switch. This is a double replacement reaction. So those are the 5 major types of reactions and sort of how to identify them. Again, the only ones I usually see people confuse are single and double replacement. So just be careful with that. If you see a single atom, that's going to be a single replacement. So anyway, until next time, I am Derek Genova. Have a delightful day.